Hello guys, thanks for coming in. And we have very good turnout today and have a online audience. Thanks for tuning in. All right, today we are honored to have Jason Wen. Jason is the founder and the lead developer from sunnypilot. Sunnypilot, if you don't know, it's an open source driver assistance system that provides enhanced driver experience for over 300 car makes and models. And you just know, sunnypilot is quite popular. They have active users, more than over 3,000 active users. And Jason shared a funny story with me why it is named after sunnypilot. It's close to Florida. When he started the sunnypilot journey, in fact, in Orlando in 2021, close to right at our neighboring cities. Very good end. Sunny's research and development focus on creating customizable driver assistance systems, which empowers users to manage their own driving profiles according to their personal preference. He implemented safety enhancement by following established fail-safe redundancy measures at the hardware level, adhering to ISO standards while making significant contributions to safety code optimization and conducting rigorous testing protocols. Personally, I have been a big fan of sunnypilot. My students have used the sunnypilot to collect the data over the past few years. It has been a great experience for us. And I strongly encourage you and recommend you testing out for yourself. Yeah, we will also provide opportunities if you're interested. So in our lab, we regularly do a lot of data testing, data collection from different rental cars. Yeah, let us know if you're interested. Also, if you have questions regarding the development of technical details for sunnypilot, feel free to ask it at the end of this presentation or drop an email to Sunny. Okay, without further ado, let's hand it over to Sunny.
Thank you, Dr. Joel. And thank you for the opportunity. So, hey everyone, my name is Jason Wen. I'm the founder and the lead developer for sunnypilot. And this session is just talk about the open source driving assist and its implications on for transportations. So today we're going to talk about how I started sunnypilot, how the journey has been, and what it means for the drivers, for developers, for the infrastructure, and for everyone in the world, and how to improve driving and infrastructure altogether. So, and most importantly, how the open source model is going to change how we do with the advanced driving safety systems that's currently out there. So a little background to myself. I'm always a car guy. So since I was young, I always loved working on cars. I do my own brakes, my own oil changes. And in college, I got into some sports car modifications on the engine controls and whatnot. And then after that, kind of grew out of it, and I want to get into the software realm, and that's kind of when I got around to the openpilot back in 2019. Openpilot, it was a software that's developed by Comma.ai. You can look in the website, just comma.ai. It's really, they have an open source this ADAS system that's out there for anyone to use for free on their proprietary hardware. And I just kind of got fascinated by it. Back in 2019, I drove a 2019 Honda Accord and just slapped on a cell phone on its windshield and then just started driving on itself. So it's pretty cool. 2020 was when I moved to Florida for another job. And 2021 is when I started getting into, hey, I want to do something more than just using it, right? Previously, 2021, I've been always just a user. And then after that, I was like, hey, I want to get a feature that I want to get on working for my car, because back then there wasn't that many developers in the community that's able to offer something this customized for a specific vehicle. So that's when I kind of got into it, and got my own feature that was written throughout some references from the forks and all that, and it got working. Fast forward to 2025, we have over 2,000 to 3,000 active users that's currently using sunnypilot, that's actively using in their cars and just driving on the road, just plug and play, and it's been a journey. So you can kind of see right here in the picture, I was taking off the bumper to get access to the radar unit that's for the adaptive cruise control in my car, and this is a 2021 Hyundai Sonata. So essentially allow me to get full control of the computer over here that allows me to do whatever controls I want with sunnypilot. Currently, I am an active contributor in the sunnypilot community and also openpilot community that's maintained by comma.ai. I've been doing active card ports, essentially adding more cards on the supported list. So right now, the software stack is pretty simple. It's a couple lines of code and some validations on the continuous integration, offline testing, and the cards will just work. It's pretty simple right now to get a card to work. And my goal is just to get as many people to know this community as possible and get as many cars on the road to get to use openpilot, sunnypilot. Yeah, so far it's been pretty good. So as all we go, I all started with like, hey, I thought it was easy, right? Took me 2 months to get that one single feature to work, and that's a saying. We do this not because it's easy, but because we thought it was easy. And this is the same thing that we talk about within the sunnypilot team every single day. Every single day we thought, hey, let's add an API to this SunnyLink backend that we have, right? So some bugs just came through, and sometimes it took about 3 days, 4 days, which we thought it would take like 30 minutes. But sometimes the development just goes. But with this in mind, everything is worth it, and everything is just fun to work on. So the open source community is what makes this project thrive, and we'll get into this shortly. And so for today's seminar, we're going to cover what is sunnypilot, what is openpilot, and the technical architecture for sunnypilot and openpilot for this entire project. What's the real world performance, the research implications for infrastructure, and also kind of look into the future of open source ADAS, how we can improve it, how we can utilize the data, and how we can contribute to the project and the world. And also how you can also get involved today. So ADAS stands for Advanced Driving, Autonomous Driving Assistance Systems. So the current landscape is that we know, anyone drive a Tesla here? Okay. Have you used the FSD beta?
Yes.
Do you like it?
It's like if you feel 40 years old, be permanent.
Okay. Gotcha. Yeah, so as we know, Tesla's FSD beta, it's out there. Anyone can get it for ranging from $99 per month or to $15,000 at the highest peak for a one-time payment to get access to the software. And also General Motors, Ford, they have their own system. It's called Blue Cruise. General Motors have they call Super Cruise. There's a lot of different stuff. Mercedes also has the level 3 system as well that everyone can get access today. Some of the issue is that, or some of the things that the limiting is that it's limited to just a certain vehicle or certain make and a model. So let's say you have a 2015 vehicle that has none of these, like you cannot get it, right? So you have to get a up-to-date car that has all these systems, and you have to pay for it as well, and only limited to a certain trim. Some trims only have the very basic autonomous driving for lane keeping or even just lane departure warning, no controls. But if you want to pay for this, you got to pay more, and the system is kind of limited, right? And also, all the development that these manufacturers are doing right now are very closed source, so they don't really have any openness to the public, to the consumers, or to any community that's like, hey, like what's their roadmap or whatever they're working on internally. That kind of access is extremely limited, if not impossible for the public to know. But it's out there. It's for a couple of years. And now you have the open source system where all you need is just some, people call it a cell phone, but in this case, it's a very customized cell phone that's dedicated for self-driving and for autonomous driving. In this case, you can see this Comma 3X here from the Comma company. Right now, their lowest price is like $999, which is, comparing to back in 2022, this device was over $2,000. So the price is dropping, and you just need a couple harness that plugs into your car. As long as your car has the required hardware to support it, just plug it in 30 minutes, and you're good to go. You can drive on the road, set the cruise control, and your car will just drive itself, steering and got the cruise control. Currently, so-called open source system, in this case, openpilot, sunnypilot, it can work on over 300 production vehicles that's currently on the market, on the road worldwide. So we have all the major manufacturers like Hyundai, Honda, Toyota, Lexus. Even in some unofficial models right now, let's say in the other markets, like Asia market, they have the BYD or different other manufacturers that have this similar system that can just plug in and just work with some code changes. A lot of these are just software changes. And it's community driven. Everything that you see on sunnypilot and openpilot are completely open source for the car supporting community. And anyone can look on GitHub and just look at some code, and they want to make some changes, add some new car parts, add some new features. They can just look on GitHub, and it's fully open source. So it opened a lot of doors for the enthusiasts and researchers to kind of explore the autonomy without waiting for the OEMs. Like, oh, we got to wait for 5 years for some manufacturers to release a level 3, which it is very geo-fenced. You don't get access to a lot of scenarios or environments to use the system. While this open source system right now, it's already downloadable today that you can just use it. And this way it allows us to democratize self-driving. Yeah, so let's talk about openpilot, the foundation of where sunnypilot came from. So it's founded by George Holtz from Common AI back in 2016. If you are not familiar with George Holtz, there's some background that he's the first person in the world or publicly that he has jailbroken the first iPhone. He's the first one that did it. He also was the person that kind of hacked the PlayStation back then and get you can download whatever games on your PlayStation back then, without paying for anything, right? That's just some projects I had done. And at some point he got into the self-driving scene, and then he started the company in 2016. And now in 2025, the company is still thriving, and they have over 10,000, 20,000 users on the road. openpilot is a vision-based driving assistance system. So it is fully relying on the front-facing camera on the driver's road, on the driving road, and it will inputs all the model context, and then it will output the controls. We'll get into it later, but essentially, simply put, it's just a SOM that is attached to your windshield with a cell phone with the 2 cameras that's looking at the road and address itself. There's no additional sensors that's required. There's no additional hardware that's needed to get this to work, other than just have an interface that talks to your car, and it'll just work. It is a level 2 autonomy, which is ADAS, so driver supervision is always required. So these systems are very, very smart, but also they sometimes still do make mistakes. So as a driver, you still have to be in control of the system whenever it makes mistakes and correct it. And it's very, very simple to take over. It's very chill to drive. And it's also open source. It's on an MIT license. That means that you can go into it on the GitHub today and fork the code, and you can use it for your research, for personal use, for anything, and it's fully open source. And this is where sunnypilot comes in as a community-driven enhancement. So sunnypilot is essentially a fork of openpilot. We relied on a lot of the infrastructure that openpilot, the Comma team has set up within openpilot. And we are very lucky that we're able to leverage a lot of the safety systems and quality management within openpilot. So on top of what openpilot really offers, we added a lot of enhanced driver customizations that certain users or drivers may want for their specific needs while they're using this driver assistance system. There is specific vehicle tuning. Let's say you want the steering wheel to turn smoother, or you have some algorithms that you're working on that could make driving better. This is where you can kind of, as a user or as a developer, you can go in and make your own changes on your own without waiting for anyone. So you can just load code on this cell phone and make the changes, and you can just drive and test it out. We also do a lot of extended vehicle support. So openpilot currently supports over 300 vehicles that's currently on production on the market. But there are some vehicles there's some lower trims that do not support this natively. So this is where we kind of come in and we offer that level of support within sunnypilot. So We do offer additional 10 additional models or makes trims out there that we do support. So this is a level that we can expand this software more out to the community. And we also offer some, like user interface, right? So you can see here on the screen on the left is we just added some more additional metrics that users or developers can look at, like how much steering you're doing. Are you braking, or what's the distance of the car in front of you is at? It's down to accurate to the decimals, right? And you can also change how it performs. Do you want it to stop at a stoplight? Do you want to stop at a stop sign? Do you want it to go on its own when it's a green light, etc.? Do you want it to follow the car closer or further? You can also adjust how much you want to keep the distance with the vehicle without using the presets, right? So there's a lot of these additional features, and you can also see at the bottom right here in this picture, we offer a lot of different driving personality, different controls for some of these vehicle controls. So we offer a bit more features on top of openpilot, but the most important part is that sunnypilot is fully open source with its controls and everything that we have on GitHub. This was done back in July of 2024, which previously we were closed source, and then at some point we decided that it's best that we just open source it because it's a much better model that for the community contribute and actually see what we're doing. In this case, it's just what's transparent. All right, so let's kind of get into like the very small things on like how the architecture works, how you get this sunnypilot, openpilot to work, right? So Comma.ai, they developed this customized Qualcomm SOM that allows, there's two front-facing cameras. This is the wide cam and the narrow cam, which looks far, and this one more of the context for the model to process that scenery. So this is the hardware that openpilot and sunnypilot runs on. It's got enough compute for running modern machine learning models that these machine learning models are currently trained and published by Comma exclusively. And this is the device that allows you to interface with most cars. It's very plug and play. You can see right here, there's a little port right here. That's the thing that plugs into another piece of harness, and then it talks to your car. And that's it, just one cable. It plugs into the camera in the car, and it just works. And also, there's a second level of the hardware is that it's called Panda. So why is it called Panda? I believe what to my understanding was that it was called Panda because back then the color of this chip right here was black and white. But I could be wrong, but that's kind of like back then they call it that the white panda, gray panda, black panda, and right now with the red panda. So it's just a different processor that processes the CAN traffic from the car's CAN stream. So the Panda essentially is a secondary processor that allows you to directly interface with the car. So when people see that you have the Comma 3X, right? But this is not actually the device that talks to your car. It's actually this Panda. So this Panda, this is an external Panda device, but in every Comma 3 and 3X, there's an internal Panda already inside. And this is what allows the software, sunnypilot, openpilot, and the Comma 3X to interface with the car. So this enforces a safety model that Comma currently observes. It's running on Missouri quality code standards, and also it's code rigorous. It's very strict. So this allows that sunnypilot and openpilot to be quality management. What that means is that this is where it enforced at the hardware safety level, where let's say you were trying to drive down the road, you want to make a left turn, or the model wants to make a left turn, but for some reason there's a bug, there's an issue within the openpilot, sunnypilot code side that all of a sudden wants a 180 to the left on a highway, right? The Panda, the secondary processor here, is where there's an internal check where it limits the amount of actuations that allows sunnypilot, openpilot to actuate the car. So this is where the safety check happens. It's a hardware level safety check where if it detects there's a violation on the amount of actuation that the car should not be doing, it will just cut off it will just disallow all actuation. So this is a level of the safety that's implemented with this device. So it is running on the ASIL, so it's automotive safety integrity level. There's multiple publications on this. You can kind of Google it, on your free time to kind of see how it works. But essentially, the ISL-D for Delta, which talks about the steering level safety, and then also there's another standard that talks about the adaptive cruise control safety as well. So rear gun interface. So it's really the hardware, the Comma 3X attached to the car. I haven't got a picture here, but there's a harness that allows you to access the camera, where you can allow the Comma 3X to write and read the data. It's got the canvas integration. So essentially, if the car is on canvas currently, CAN or the CAN 2.0, which is also called CAN FD, you can just plug this in and then make sure we can read and write the actual APIs that the car needs, and then it will just drive. And I have a sample picture here. This is the 2025 Hyundai Ioniq 5, which is an extremely fast electric vehicle that's currently in the market, and it just works. The user just plug it in, and it'll just drive the car itself, and it drives fast. So vehicle integration process. So I could go on this topic for probably weeks because the topic is so vast. There's so many things you could do. So I'm just gonna quickly go over the overall process. There are some talks on YouTube as well. That's another community contributor. There was a Comic-Con back in 2023 where he did a talk on carporting, which is getting your vehicle and its vehicles that's currently not supported to get it to work with openpilot or sunnypilot. So top to bottom is just really, we're trying to understand what the canvas signal means to reverse engineer. So you can kind of see we have a lot of tooling within sunnypilot and openpilot, where you can kind of see you can just load up what we call a route in a segment, which every time the camera comes on the Comma 3X, it will just record all the data, CAN traffic data, the telemetry within whatever we're trying to log within sunnypilot, openpilot, and it logs the video stream as well. So this allows developers or anyone that's working on carporting can come in here and understand what this means for the data, right? So in this case, with the demonstration for adaptive cruise control, this is for the Toyota RAV4 2017 to 2021. You can kind of see what kind of acceleration it's getting when it's trying to go forward or backwards, or what kind of commands the car is expecting, and what are the responses from the car that we're seeing. So this allows us to kind of get one understanding to get the API to work correctly with the car. There are also safety validation protocols. So whenever we try to port a car, we try to understand what the maximum actuations or what the limits that this car can perform. So what we do is that we will get some code to kind of, we will review the data first, and then get some code on the device, and then we'll try to drive it, and then kind of see, like, if we command this amount of actuation, what would the car do? Would it go super fast, go forward, or would it just crawl on its own? Would it steer too much to the left? It's trying to do a 180, like drifting in the parking lot, or just go like a very, very slow kind of steering, right? So that's kind of like where we, as carporting, we're trying to understand what those limits means, because we do want to adhere to some of the safety standards, which we will go over in the next slide. And then we're just trying to understand what the different APIs mean. So different car manufacturers for CAN, there's not really a standard on there's no standard on what the messages structure means, right? So you can see right here on the screenshot, you see it set ACC control, and then it tells you what the actual command for the acceleration. Some different manufacturers, for example, Chrysler, I know for the Chrysler Ram 1500 for their pickup, they have the acceleration command as torque and engine RPM, and we don't have a direct access to how it works. So to understand, like, how do these different manufacturers how do we by understanding how the API works natively, and then that's where we try to understand more, and then make it validate on the software level side within the CI/CD with the unit tests that we've integrated with the sunnypilot and openpilot, and go from there. So that's kind of high level on the hardware side, kind of understanding how it works. We're getting to the software stack. So Python, C++, it's kind of the majority of sunnypilot openpilot. This is kind of a screenshot from our GitHub, where you can see kind of the percentage of certain languages that's within the entire code base. So you can see about 40% is Python, about 40-ish% is C++. There's a UI code and a safety code and all of that. It's a majority. It's shown here. So the key component is that the how it works is it's a vision-based perception. So there's a machine learning model that's deployed offline that's living on a device. So when sunnypilot and openpilot is running on runtime, this model is actively trying to ingest all the inputs from the camera and all the sensors that Comma 3x has access to, and then it will process. It will do a planning through the MPC, and then at the end, it will do an output from the machine learning model, and it will do lateral or longitudinal, which is steering and braking and accelerating to within the Python side. There's a lot of vehicle-specific interfaces because, like I mentioned earlier, each manufacturer has their own different interface for the CAN traffic. So we do have to have a different interface for certain manufacturers. And luckily, once what we figure out one model for that single make or manufacturer, luckily we can use it for all the different models within the car brand. So Hyundai, Kia, Genesis, if you didn't know, Hyundai is kind of the parent company with Kia and Genesis. And once we get one Hyundai Sonata working, all the other Kia and Genesis just works. We can just use the same API, and it will just interact with it similarly. This device also has the driver monitoring. I didn't show it earlier, but there's a daemon that's within sunnypilot openpilot where it has another machine learning model that it sits in front of where it sits under the screen. There's a little camera that looks at the driver's face to see if you're distracted, if you are focusing on the road, etc. So let's say you are looking on your phone or you're doing something that's not focusing on the road, the model would actually understand and try to see like if you're distracted, and then it will throw the appropriate alerts to alert the driver that, hey, you're distracted, please focus on the road. And after a little bit, if the driver is still unattended for a certain amount of time, it will actually scream very loud that it almost give me a heart attack, and it will actually disengage all controls at the moment. So how does see the road? I'm not a model guy. I'm going to be very honest. We have a model guy on our team. So, but the overall understanding is, we do kind of see how it works. So I'll go over very quickly on how we actually perceive the world that the model is seeing. So there's a dual role camera vision system where it looks on the road, and there's a narrow cam and a wide cam, and it's on a machine learning model that it predicts the curvature, the yaw rates that the human would do. So it's very interesting that the current modern machine learning model that Comma has released are end-to-end for steering controls. What it means is that it will just look at the scene without looking at the stoplights or the roads, or we don't tell the model what to look for. It will just look at the road, look at the picture, and then it will just output like, hey, I think at this moment a human driver will do this. Output the data, and that's it. So there's no hard coding on like, I want this amount of steering when I see this lane line this far from me, or how far the stop sign is, whatever. We don't tell it that. It will just ingest all the context, and then it will just output the data, just like that. And then also this machine learning model also predicts the positions, the speed and acceleration from humans. So that also have the outputs to command acceleration and deceleration for the vehicle. So the adaptive cruise control systems. This model does not rely on any high definition maps, and some manufacturers out there, for example, General Motors, the Super Cruise, right? Level 3-ish, I say ish because it doesn't work all the time. And then there's the Mercedes, also level 3, that allows you to do hands-free, and you just look at the road and you just drive. The problem is a lot of these, they require geofencing, which means that you can only activate that level system within that stretch of the road or that stretch of the area or this highway. So it's very limited, and you don't get to use the system a lot if you're not on that stretch of the geofence areas, which is a limitation that a lot of these OEMs are currently still facing. Tesla's is the only car manufacturers out there currently, other than Comma, that has their model end-to-end, which they do not have any reliance on these HD maps or reliance on these lane lines or markings or whatever. It's similar to how Comma has it with the machine learning model. Let's just look at the scenes, get in the context, and it gets outputs out. So it's pretty smart. Let's put it that way. So from perception to controls, the model knows what to see. It kind of knows what the human would do. So let's say we want to dismount control. How do we get it to control the car now? So the path planning, it's based on the machine learning model. There's a PID controller that's on the software side where it handles all the lateral control, which is steering, and longitudinal control, which is adaptive cruise control. There's the model predictive control, what we call the MPC, which smoothens out how steering it should be executed and longitudinal should be executed. And there's a couple other layers of the controllers that makes that smoother. But the MPC currently it's being used within sunnypilot. It's running on 100 hertz for the control loop. So most of these systems out there for the manufacturers for the steering and their adaptive cruise control, they're running 100 hertz, which allows the very precise controls whenever we try to send the same amount of data as well to control the car. Safety and standards. So sunnypilot and openpilot, we do observe a safety model where the driver must always be able to take over of the vehicle. What that means is that, let's say the system is behaving abnormally, or there's a bug that's in the code, right? And it's not doing something that we expect the vehicle to do. Let's say steer on the road, or it's trying to like drive so fast it cannot brake when there's a car in front of you. So this is where we implemented that the driver must be able always to take over by either canceling the cruise control or pressing on the brake to cancel the cruise control for steering, button press, etc. There's a main control that the drivers must be able to take over. The second point is the vehicle must not alter its trajectory too quickly for the driver to safely react. What that means is that, let's say on the highway, you're going, let's say 75 miles per hour, no big deal, just kind of cruising on the highway on its own. All of a sudden there's a bump, or all of a sudden there's something on the road, there's a pothole that bumps the car, right? And the system might get a little wonky, the models might look something differently, and now it's trying to say, hey, I want to adjust, I want to do something that we weren't expecting, or could do a 180 or whatever. The safety model allows us to kind of limit that and kind of observe what the amount of limits, actuation limits that it's allowed the car to do. So this does not allow the vehicle to go off the road, or the driver doesn't have enough time to react. Let's say these edge cases do happen. We do observe the ISO 11270. It's some of the safety guidelines for lane keep assist systems. It's all out there. It's all published. You can kind of take a look at how it works. But there are some very nice languages in there of the limits on all what we should expect on different vehicle speeds for these kind of limitations. Also, the 15662 is for the adaptive cruise control guidelines. Also, it's indicated there's some languages that we can follow very easily. It's only like 15, 20 pages. So it's the languages are pretty simple to go through, I would say, just to understand what do these limits mean and how are they being perceived in this kind of safety systems. Also, ISO 26262, functional safety for road vehicles. It's kind of like there's a lot of edge cases, one of case studies that these documents do discuss about, and also it talks about some of these guidelines as well. So it allows us to kind of follow the standards throughout this kind of realm, and allows us to understand what it means as far as the safety. So let's say someone trying to understand it, we have very explicit language that allows anyone to just look at it and know exactly how it should be. So how does sunnypilot and openpilot works with current infrastructure today? It is designed, or I would say it is not designed, I would say it just works for the existing infrastructure. There's no modifications needed for any road. So there are some cases out there where there are some local governments that's trying to like, hey, we want to get these roads with clear lane lines, so these systems can just work, right? But with sunnypilot and openpilot, it does not require any lane marking for it to steer. Anything to kind of say, this is the lane line, please drive here. Like I mentioned in the previous slide, it will just take the context from the current scenario, and then it'll process it as in like, what would a human do when there's no lane limit, right? So most humans will just kind of stand on the side of the road and just drive, but they won't just like go all over the place, right? So the model is able to understand that, able to process that. So that's why there's no need for these infrastructure changes just to make it work, because it just works. The model just processes the data, just works. So adapts to varying road quality and marking conditions. That's similar to previous points. You can kind of see in the bottom left right here, you can see all these main roads here. There's the lane lines, right? All these lane lines and the predicted pathing here. But you can also see these are local roads. The lane lines is sometimes just a tar line in the middle of the road, right? And it's able to see the curve just kind of rear left, and the model is able to actually outputs the controls and allow the controller to actually execute the controls. So there's no limitations to those. Across diverse environments, I've used this on highways, I've used it on urban roads, even off roads in the desert. I've seen people from the Middle East, in the UAE, where there's a lot of deserts, right? They just there's kind of a path where some of the off-road cars just kind of in the desert, and someone just engaged it. It just followed that path. That tire is made, and it just works. So there's just the model just kind of knows what a human would do, which is pretty amazing. So there's from the model, there's a lot of these outputs that allow us to kind of use it for whatever purposes. Previously, with openpilot, these models were linked, like they are not end-to-end, which means that they do require the lane lines to kind of be there and understand them, right? But also it actually sees, it's not showing here, but if you look at the interface on the screen, you will see like a little red line right there telling you that's the edge, that's the edge that's right there. So it's pretty interesting that the model has a lot of data that's out there, but it's for sunnypilot purposes. This just controls outputs from the model, and it just works. So as far as for how sunnypilot develops, it is running on a community development model, which we do have a very transparent peer review process. Every change that we make in the code for sunnypilot, you can actively see on GitHub today. So it's GitHub/sunnypilot/sunnypilot. You can see all the active development that we do there, and anyone can take a look and review and make any suggestions, etc. We run a very rapid iteration cycle, so we don't rely on a certain time frame, but we do like when we make a change, we just open the pull request, we make a change request, and then just merge into a master branch. And we keep iterating. We don't wait for certain things that's like a blocker or whatnot. In some cases, there are a lot of these developments, they can be very parallel. And that's what we're trying to work towards as well. And this kind of democratized all the development priorities. So currently we are going over a rewrite for all of these features from our previous release. So basically what we're trying to do is rewrite sunnypilot from the ground up, which we have a lot of features and a lot of code. So we're trying to go over things more, more rigorously this time around, but it also allows us to kind of prioritize what the community wants. So we are going to do a poll at some point, like, hey, with these features that's not done yet, what do you guys want to see? So that's kind of, we have that kind of community model that allows us to kind of get feedback from the community directly and implement in our development process as well. So it's pretty cool. So what are the potential impacts on the infrastructure? So open source means that we have a lot of data out there, that the model can just see and just kind of collect, right? So transparent interpretation of row features. So the model is able to see about the context, but it doesn't really do much right now with how the model is doing. So at some point, the models could kind of advance to a point that it will kind of just see the context and it will just return what it wants to do, right? So it also allows collaborative improvements with the infrastructure planners. A lot of these was just that, let's say, for example, we are driving on the road, the car with the comma 3x. At some point, we are allowed to get the data that's collected by the software, and then we're able to analyze the data to kind of understand if there are any improvements that we could make to the infrastructure. I was talking to Dr. Joe yesterday, and we were talking about like how we can kind of take the data and just kind of understand like, hey, maybe a pothole needs to be fixed at some point, but no one's able to report it because the agencies are kind of sometimes they have a very complex and complicated systems for you to kind of report these things. So at some point, some of these we could be data driven to make these investments on the infrastructure for improvements, for fixes on these to able to prioritize even better than what we have today. So what can we do in the future with some of these systems? Maybe we'll get ready for the vehicle to infrastructure communication standards. So currently, all the vehicles on the market that's that's driving right now, it doesn't really talk to other things, right? I mean, there's some manufacturers that has the cellular data that talks to their backend and then allows you to kind of check the telemetry of the cars and also kind of take control on some of the aspects on the vehicle, but it doesn't really interrupt the infrastructure. So in the future, some of these capabilities could be that allows some of these safety standards that could be set up so that it could look further, let's say down the road that there's a traffic congestion or there's accidents. It's able to kind of utilize these data to kind of preemptively prep the public to kind of mitigate with certain road departure or road closures, etc. Hopefully, at some point, we're able to get that kind of controls. And I believe the infrastructure out there, it's right now there has some these kind of infrastructure on the traffic lights and some of these locations around the country, but it's not nationwide because there's no actual standards or actual infrastructure or a platform that allows it to do this efficiently. So it could help out with mapping in the future as well. Then you can kind of see there's some companies out there that already has some of these capabilities where it will take an image as a context and then it will kind of just analyze like what are these. Do we need to repaint the lane lines here? Do we need to put more priorities as potholes? Right? This one looks pretty deep. It's like a couple inches deep, so it's gonna destroy someone's suspensions at some point if it's not taken care of. And there's maybe some road conditions that it could be preemptively just prep the public and just kind of benefits from there. Traffic management systems. There's a potential where you can kind of like prep what kind of data you're seeing, you're gathering from these devices, and have it analyzed at a macro level. Where on a city planner, it's like, how do we want to plan out these traffic lights? How long do we want to be? Are people taking these routes more, or etc. Google and a lot of these companies out there, they already have these data, and they're already offering all of these data with the government agencies. But it's kind of like relying just on these companies to do it, right? So going back to the very first points that we have mentioned earlier, it's kind of closed. It's not something that it's open source that's to allow the community to kind of like contribute to it. So maybe at some point we can allow this kind of a platform to happen where we'll develop something that allows the users or allows the companies or fleets of cars to use these systems to kind of interact with the infrastructure to make improvements. So going back to sunnypilot a little bit, any real world impact? I don't know about everyone, but for me, it's been a game changer. So I've been in upstate New York for a majority of my life, and back in 2020 was when I took the opportunity to work in Orlando, Florida. The drive you can see right here, I took in this last 1.5 hours of driving. This doesn't include your foods, your bathroom breaks, your rest, etc. Right? But a lot of times where most people will just drive, it's very fatigued. Where even the stock systems, you have to keep the steering, you have to look at the road, you have to like see how far the car is in front of you, right? And there's some level 2 systems out there on these manufacturers already offer something like this, but it's still not as chill because a lot of times they do rely on a lot of lane marking to keep it work. Let's say you get, for example, get South Carolina on the I-95. There's a lot of roads that are not well painted. So on those roads, at some point I was testing it there, it actually just disengaged completely, which I had like obviously I was paying attention, but it's very stressful. It's very fatigue, especially for an 18-hour, 19-hour drive, right? So I've done this round trip, so New York to Florida and backwards, round trip 3 times with sunnypilot. And I would say that it's been the best. Like it's like you would never get this kind of chill driving at all because all you do is just that as long as you look in the road, your hands could be hands-free, you can put it on your lap or on the center console. It will just drive for hours and miles after miles. As long as the system is operational, it's within the safety limits, and there's no system issues, it will just work for hours on end. And it's very consistent on controls. And for the safety purposes, let's say the driver is fatigued, right? But some systems out there, they say it works all the time, but some you rely on it, so you just kind of lose that kind of safety, so which induces more fatigue and stress. So this enhanced safety in the point that is just makes everything better. And then also the impact is that it democratizes access to these advanced technologies. Like we talked in the first couple slides, we really, without this open source system, we're just really relying on the manufacturers offering these. So yes, like for example, I had the 2023 Genesis G70. It has a system, it works, but it never updates. And these newer manufacturers, they said the newer models, they do offer OT updates, over-the-air updates, where updates, over the air, you just need Wi-Fi and it just works, but you're still limited to the manufacturer offering. And maybe someday they'll do it, maybe they never do it, you never know. This allows you to use a system. You can look at the sunnypilot on GitHub or openpilot on GitHub. You can just see updates 20%. Like we always come into there. You can see exactly how the development goes, and you can make your own changes at any time on how it works for your needs. So research opportunities, it could allow access to a lot of anonymized driving data sets, which allow us to understand more on how the cars on the road today interact with the infrastructure. It's a test bed for a lot of end-to-end learning approaches. As I mentioned a couple of slides before, the current machine learning model for lateral for steering control is end-to-end. The Comma team, the openpilot, they are working on a end-to-end longitudinal as well. How they are doing some of these model training is that as previously they were taking data from a real-world driving data from the users, right? And then they train the model. Currently, they have a new approach where they take all the models, all the data, and they train the model within a simulation. It's within a simulated environment where it's just kind of let the model do this thing, and then they make adjustments to it. And it's something that they're working towards of, and it's something that a lot of researchers and a lot of the agencies out there could utilize moving forward. Transportation intelligence tree modeling. You could probably do a lot of these behavioral modeling and a lot of these, I want to say, publishes on industry partnerships of a lot of these things. So you could probably work with a lot of different agencies out there, industries out there to kind of improve the infrastructure as well. So for sunnypilot, for the development roadmap, we're trying to kind of enhance the perception in some of the conditions. So we don't train the model. we're very lucky that we're able to leverage what Comma, the openpilot team can, the research team on the Comma side to have these models just available to us. So this is the great thing about open source. They push it to GitHub, and we're just able to just pull it in our device, and it's just a complete different experience, a better experience per se. We are trying to, on sunnypilot, trying to get more of these road conditions to a more specific approach where the current model, machine learning model, it just kind of see the context, right? But for me personally, I want to see the speed limit. I want to see, are there any different traffic lights or the different signs, or if you have used Waze before on your phone, you can report accidents. You can report, I think right now potholes, right? As we mentioned, and also there's reporting different events that's on the road. I do want something that allows sunnypilot to do that moving forward, and that's something we're currently trying to research into and develop into. We're trying to get more cars on the road to use sunnypilot. So we have over 300 vehicles models that's currently in production, with additional 10 that sunnypilot do offers. But there are so many cars out there that it will probably work all over the world. I do know in Indonesia, in Southeast Asia, China, they have a lot of these different manufacturers that utilize very similar systems that allow sunnypilot and openpilot to just work after some code changes. Right? So that's something we want to work towards. Sunnylink. I haven't really talked about Sunnylink, but just a kind of preview because we haven't really it's not really a public release yet. But we do want to make it to expand more and more features, allow the users to kind of interface with a lot of these things. So you can see right now we have some ingestions of data, like there's some beta, internal beta that allows us to kind of see what kind of information we can collect. NPG consumption history, your recent trips, your vehicle information, your performance, and your previous drives or previous 10 drives, and what's your average speed, your odometer right now in your car. Even at some point, we do want to expand that. There's vehicle management as well, where it allows you to like schedule the maintenance with your dealership or whatever, and all within this portal. And currently, Sunnylink, it is kind of ready to use for 1 or 2 features, and it will be completely free for the time being. We do want to improve urban driving capabilities where at low speed driving, steer better, make better curves, and slower speeds within stoppable traffic, and the heavy traffic where it drives smoother. That's where a lot of the tuning that we are doing in sunnypilot right now. So we are able to make specific tuning for steering and adaptive cruise control. So do you want to just launch control it and go as fast as you can when the car lifts off, or you want a very smooth or very distance, very good pattern on how the car follows the vehicle or how much it turns. That's something we're working towards as well. And we do have a team that is actively working on this. And I do want to thank them here for the time that's been on sunnypilot. So here's the team right now. We have 78 developers. We do have 2 testers. So the team is growing. These are we have different expertise in some of these areas. So me, I'm just working on everything. And dev tech, I never get his name, but that is the Discord and GitHub name. He's the main developer working on Sunnylink side, and he also drives a Hyundai Ioniq 5. Kumar is the guy that's the Toyota guy. He's kind of the community expert since 2019, 2020. So he's been a very good asset to our team as well. A lot of longitudinal tuning. He's a subject matter expert. So if someday you're interested and you want to get a truck drive better, and you have a Toyota at some point, maybe this is the guy you reach out to. And we all reachable on Discord and all that. So, Isaac is Sunnylink front end. So what you saw earlier with this UI, he made all of that on his own. Took him about a week or so of total development time, and it's just something nice to see for everyone. So Isaac drives a Ford, he drives a F-150, and very active in the community. And this Count Chubbs, he's our recent developer that just joined the sunnypilot team. He's working on some of the machine learning approaches to how we do tuning for the adaptive cruise control, and he also drives one of the Honey Kia series. Roy Jr. He's also one of the new developer that's just joined the team. He drives a Sonata that's he's actively reverse engineering all the CAN traffic from his car, so he's just trying to get his car drive better. And then we have two testers, Brian Tron and Stoop. Stoop has been a very he has been in the community for quite some time, also a veteran in the community. A lot of insights from him on some of these testings are very valuable to the team. So we cover a lot of the areas. We have people that work on controls, people work on the website, the backend, testing environments, and also we have the machine learning approaches as well. So we're trying to grow the team a little more, but everyone is happy to work on it, and I'm glad everyone's enjoying working on this. So yeah. So last but not least, I do want to. So sunnypilot isn't sunnypilot without the community. So as I started sunnypilot, me and I believe Brian Tron, this tester here, we were the only two users on sunnypilot. But as we kind of got it out there, people just started getting more interested in sunnypilot, on the feature sets, on how the reliability and stability of sunnypilot. People just started getting on, and at some point we started get up sponsors and Patreon, and we grew over to almost 7,000 members on Discord. So we do a Discord server because sunnypilot. You can look on our website as well. We almost have over 7,000 members. Just people using or not using, they're looking around. That's the community that we're currently in. So sunnypilot isn't there without the community. So I do want to take the time to thank everyone in the community for the support during these times. So yep, and that's my talk.
Thank you.
You cracking this time around?
Excellent.
Yes.
So you mentioned that sunnypilot does not rely on lane markings, but I want to know when you are testing sunnypilot, if there are lane markings, does it help with the steering, or like does it improve how your model works?
So the model does outputs that it sees the lane lines, right? So we talked about the context of what the model sees, the cameras. It takes an image, or takes the scenario, it processes it, and then it outputs the actual outputs from the model. So we do see the lane lines that it understands it, but it does not explicitly take it and be like, hey, this is where I want to be because it's the lane line. It does not do that. So it's taking the end-to-end approach where it will just think how a human would drive, and then it outputs the actual controls, allowing the controller to steer the car. So to your question, it doesn't really like make it better, but it would say that it does take in the context that maybe like if a human sees this, maybe he will do this in this scenario, right? So some cars, like let's say you're driving on some roads, there's a curve, right? Let's say the road was 45 miles per hour, but now it says 30. It's like some people said like you wanted the car to drive like a train on a train rail, right? You stay in the middle and you steer. But sometimes on these steep curves, you're not really staying on the middle of the lane, right? Because otherwise we should use centrifugal force just to force you out. So some people like, just real world driving, you're gonna cut in a little bit to the inside curve. So not like you're sitting on the lane, but you're like near it. So the model is able to understand that and actually outputs that. Like let's say going around these curves right now with sunnypilot and openpilot, it will actually do exactly that. It will kind of like veer to the to the other side, the inner side of the curve. It will just kind of mimic how a human would drive. So it's just more comfortable. Because if you're just driving like a train, like on a train rail, you make a turn, you will feel all the force going out, right? So it's just so it will help, but it will not explicitly execute the controls based on the lane.
So how well does sunnypilot adapt to like harsh weather conditions, like a lot of fog or there's heavy rain? Is it still like go through the road, or does it have any issues?
Yeah, so that's something I was gonna put in the slide, but I forgot. So it does work in heavy rain, in fog, in some situations where the camera is able to see the context, right? So if I'm not sure you have done this before, but let's say you're driving on a heavy rain or fog. I know Florida has a lot of rain. And you could you can't see the road. But maybe at some point you pull a camera and you take a picture or video, it's clear state, right? That's kind of what the cameras on the Comma 3X device sees to. Obviously, if it's like very bad, it will have some mistakes because it's confused. There's a lot of like distortions in the actual image, right? But most of the time, in my experience, it has worked like extremely well. Where I wouldn't say rely on it, but using it as like at the end of the day, it's level 2. It's a driving assistance system, not a self-driving, fully self-driving, right? So I kind of like have my hands over the steering wheel like this, and my wife sees it too. Like, oh, like my hands over it, but I just kind of hover over. I'm not gonna touch it, just hover over it, and it just goes through it. Like it will see everything. And so fogs, rains, and I think sometime in the snow, like in the north, there's a lot of snow. There's a lot of Canadian and users that in the very not I want to say rural, but they have a lot of snow on the ground, right? It's able to follow the path that the previous cars have big a path to. So it does kind of try to see how a human would drive, like the end-to-end model, right? So it's pretty smart in that sense. And this has happened, like I've been using it since 2018, and back then, this device you saw, the Comma 3X, it's like so you kind of see right here, this looks like a very, customized device, right? Back in 2019, 2018, it was literally a cell phone. Like you were a Leco phone from China, and then they just made it work. And even now, with more modern machine learning models, it drives even better than 5-6 years ago. So yeah, it does work pretty well in a lot of scenarios. Questions? Yes.
You mentioned with regards to safety, that the driver must be able to take control of the steering. How do you ensure that the driver must be able to?
I'm sorry for the last part.
How do we ensure that the driver must be able to control the steering?
You're saying when the driver wants to take over.
Can you go back?
Oh, safety. Okay. Yeah.
Okay, so the driver must be able to take control of the vehicle. How do you ensure that?
So right now, let's say you can engage a system, right? And the sunnypilot, openpilot is controlling the car, steering and ACC. Let's say you want to take over. We have explicit exits, where it means is that in the safety code and also on the Python side for sunnypilot, we do have explicit controls where conditions where when a certain execution or operation of a control from the driver, it will disengage. So for example, for adaptive cruise control, it's going forward and backwards, right? But let's say for whatever reason, the car in front of you went from 70 miles per hour to 10 miles per hour in like 2 seconds, right? So in this case, I would say many systems out there, they will engage the automatic braking system, but even then, the driver is like, they want to take over. In this case, all they do is just press the brake pedal. So once it's engaged, there are many ways for the driver to disengage. So we don't say like enforce it, like once it's engaged, there's no way to disengage. We always have many ways to allow the driver to disengage. So for steering, Tesla has it where that when you override the steering wheel, it will just disengage completely, right? For sunnypilot, we do kind of have that for Tesla because it's really integrated, but we do have different modes that allows the driver to kind of either press the button to disengage steering completely, or with different modes where you press the brake, it will also disengage the system completely as well, or you press the brake to temporarily disengage or to pause steering, and then you allow the brake, it will resume steering. So we offer a lot of different experiences and different conditions that you can disengage, but this goes back to where it is. Let's say you're driving and you're steering, but you want to like override it. Let's say it's making a mistake. It's going over too much of a lane line, right? The model wants to go there, but you don't want to. But in this case, you can just kind of take over and just steer. It will allow you to steer very, very lightly. So there's something called a driver override, where if the system is engaged and you take over as a driver, a manual inputs for manual torque, the system will actually it will actually prioritize what you're steering and it will just allow you to take control very easily. So all of these systems, all, like sunnypilot and openpilot on all the cars that's supported right now do allow that. Yes.
Hi, Jason. Thanks for the presentation, very informative. I think you mentioned access to an anonymized data set. I think researchers in our community be pretty interested. So can you talk a little bit more about how can we access them and what's being offered there?
Okay, so
Is it part of SunnyPilot, SunnyLink?
it is SunnyLink. We don't have any data sharing at the moment. We haven't designed to that far, nor we have anything out there right now that's usable.
And we know Comma has a lateral steering data set, so we
Yes.
expect to see more, including longitudinal control or even the videos.
Mhm.
You shared some privacy and security, so we're wondering how SunnyPilot plans to share anonymous data set with security.
Right. So I haven't really gone over SunnyLink, but we'll take a time to talk about it here. So SunnyLink is really a platform that allows you Okay, we'll talk about it very quick. So SunnyLink, we built on AWS, everything is serverless at the moment. All communications between the device and the backend is completely encrypted. We made it within the mind that everything must be encrypted because we do value privacy for these data, for all the data that gets into SunnyLink at the moment. We do try to go GDPR compliant, which makes it basically compliant everywhere in the world. So all of these privacy, we do want to make sure that it is retained to whatever the user is getting access to. We do not want to see your personal data. We want to make sure that even any bad actors get through the security on AWS on their backend. It's all encrypted. There's no way for them to get access to the data. Even they get access to the file, to the actual content, they don't see the data because it's encrypted. So everything is encrypted on device before it gets pushed to our SunnyLink API, and everything is all secure.
Okay, Jason, do the time thing. Let's take one from the chat.
Yeah. Is there a limit on how much you can turn? Yes. So how much you can turn? We talked about the safety model. We do follow a lot of the ISO standards that's currently out there as published. We don't allow over 3 millimeters per second lateral acceleration etc. So we do have these kind of safety in place. It does not use the built-in camera from the car. It kind of uses the radar for some of these controls, but we don't really use it for steering purposes. How far does it see? Currently, we kind of see, I want to say, it sees far, but as far as like how useful the data is that the model can kind of perceive and use, it is still kind of work in progress. The first I've seen is like 140 meters. So it's still kind of development process right now, but it can see far. It's just that is that amount of information useful. That's kind of where it comes in as far as determining that. Is there any plans to make the settings simpler, easier? Yes, we have a lot of acronyms because we just kind of winged it and did it back then, but we do have a documentation page where it's going to have more details coming out. So yeah, we'll do more of that in the future. Okay, that's it.
Thank you. Thank you, Jason.
All right, thank you, everyone. Thanks for giving someone out. And if you wanna talk to me directly on Discord, I'm on Discord. You can kind of see, I have it on there. People always DM me, but if anything, if any issues, just look for me. Sunny Hype, that's my Discord name. And yeah, thanks everyone.